So I just wanted to review a little bit the ambiguous case in sine law. This is the activity that we are working on in partners and small groups before the end of class on Tuesday. So when we're using sine law, it can be a little bit, well, basically there's an ambiguous case. So when we were drawing with our rulers and protractors, we saw the case where if A equals H, so if this is triangle ABC, remember that side A would be opposite angle A and side B would be opposite angle B. So if A equals H, then you only have one triangle, and it's a right triangle. And that's the only triangle you can get. If A is equal to H, you can only have one right triangle. If A is greater than B, and so this was a triangle that we drew where B was 6 centimeters and A was 9 centimeters. And I know that this diagram here is not to scale, but you can look back in your package to see that. This would be, because of this angle here, this is an obtuse triangle. And again, there is only one possible triangle in this case. If A is less than H, so here you have H, okay? If A is less than H, and again, this was that, I think the side was 3 centimeters, then you do not have a triangle. Okay, and you can see that. Look at A ends right here. A triangle has to be an enclosed shape with 3 sides, and it's not enclosed because you have this open area right here. And then we have the ambiguous case. So if A is less than B, so in this case B was 6 centimeters, and this is only in our case, and H was 4.2 centimeters. Okay, of course, you'd have to look at each case individually. This is the one we worked with. So in this case, we had A as 5.1 centimeters. Now 5.1 is bigger than 4.2, but it's smaller than 6, and this is where you get the ambiguous case. So you can draw your line out like this or in like this. Okay, now this one here, the first one gives you an acute triangle, but this one here gives you an obtuse triangle. And so the reason why we say it's ambiguous is that you have 2 possible triangles. Okay, whereas over here you had just the right triangle, just this one obtuse triangle, or no triangle at all. Here, when you have that your length A is less than B but greater than H, you can have 2 possible triangles. In the textbook, this is page 176 to 185, section 4.3, the ambiguous case of sine law. So it works through a couple of problems, and it's got some practice problems if you want some extra help, okay? But again, it's just really more of an awareness that this is possible, and this is why we always draw out our triangles. Okay, so there'll be another video on the last section of the notes, and I'll also be talking about the test in that video.